Okay, so the next topic today is motion of connected bodies part 2. So if you want to see the part 1, you can just go for part 1 topic in playlist Newton's laws of motion. When you go to playlist in the Newton's laws of motion, there you can get connected bodies. Okay, so this is the simplest explanation which I am going to do today here. Let us consider the free body diagram. First is solution here. Let us consider what is a free body diagram of mass m1 here. So if you consider mass m1, which is going to be 3 kg, is given in the problem. So what is a free body diagram? How many forces are acting on this body here? So if you observe this body here, what is acting upwards? Tension T1 is acting upwards. What is acting downwards? M1 into G is acting downwards. So if you observe here, this is 5 kg and this is 3 kg. By seeing this diagram, it is clear that this body is definitely going to upwards, this is going to left side, and this is coming downwards here like this with an acceleration. Why is it so? Because m3 is heavier compared to m1 here. M3 is heavier compared to m1 here. That's why what are you going to consider now? So if you consider block of mass m1 here, acceleration is upwards, and acceleration is upwards means definitely resultant force is also going to be upwards here. So as the resultant force is going to be upwards here, let us see what is going to happen here. So you know that when two forces are acting, then also body is going upwards means what is the meaning here? The meaning here is T1 is going to dominate. Okay, T1 is going to dominate m1 into G. So as T1 is dominating m1 into G, what are you going to do now here? You are just going to write an equation that's resultant force is going to be T1 minus m1 into G. As both the forces are acting, then also body is going upward means T1 is dominating m1 G here. So we are writing T1 minus m1 into G here. So we'll be writing here this as m1 into A, which is T1 minus m1 into G. Let this be equation number 1 here. Okay, so let us take a free body diagram for the next body here. The next uh, concept, that is, if you observe the second body here, what is the second body here? Second body is let us imagine m2 here. So if you are considering m2 here, what are the forces acting on m2? So if you observe m2 here, you will see that tension T2 is acting left side here and tension T1 is acting right side. So acceleration is left side, resultant force is also left side here. So we can write resultant force is going to be T2 minus T1. Resultant force is going to be T2 minus T1 here. So this can be written as m2 into A according to Newton's second law, that is T2 minus T1. Let this be equation number 2. Okay, so this is a free body diagram of mass m2 here. Then let us consider free body diagram of the next body here, that is m3 into, that is m3 here. Okay, so I am taking the third body, that is m3 here. So if you see the third body, how many forces are acting here? So if you observe this third body, you know that m3g is acting downwards and tension T2 is acting upwards here. But as you know that acceleration is acting downwards here, so resultant force is also acting downwards here. So what are you going to do now? You just write here, because this is a third body, you just write here resultant force is going to be m2 into G minus tension T2. m2G minus tension T2, as you know that m3G dominates tension T2 here. Okay, tension T2. As the body, as the block is going downwards, though the two forces are acting T2 and m3G here, then also block is moving downwards. What is the meaning of that? That means m3G is dominating tension T2 here. That's why resultant force is acting downwards. Then dominating force minus lesser force, that is m2G minus T2 here. So this can be written as m2 in m3, no? Yes, m3. So this is m3. So m3 into A will be written like this. So this is m3 into G minus tension T2 here. So this can be considered as equation number 3 here. So first, second and third equation, if you observe, it's very simple now. What are you going to do now? You can find out acceleration here. How can you find out acceleration? Let us see. You just do one thing here. If you observe here, you can write tension T1 is equal to m1A plus m1 into G here. So if you observe here, tension T2 will become m3G minus m3 into A here. Okay, so these two tensions, if you take and substitute in this, okay, so substituting T1 and T2, if you substitute these two in this equation, that is in second equation. Okay, so this is second equation. This I have considered as the third equation here. This is the third. So first, second and third equations we observe. So I am going to substitute in the second equation. So what are you going to get now? So we write m2 into a. What is t1 here? T1 means you'll be writing m1a plus m1 into g here. So what is going to be t1 here? So what is t1? So if you observe t1 you have substituted here, no? Okay, so t2 means, so in the place of t2 you have to substitute this value, that is m3 into g minus m3 into a here. Okay, so this is the value of t2 which you are going to substitute here. Then what is the value of t1? So t1 is here, so minus t1 means m1 into a, minus of plus is going to be minus here, which can be written as m1 into g here. Okay, so let us take a terms to left side here. So if you take a terms to left side, what are you going to get now? You can just write all these a terms to left side, this and this you will take left side. So I'll be writing now m1 plus m2 plus m3. So this m3a left side, m1a also left side. So you can common out all these things, three things, and write a as common out here now. So what is going to be left here? So you are going to see only m3 minus m1 to the right side, which is common, and g is common for that. So if you write an acceleration here, a is going to be m3 minus m1 by m1 plus m2 plus m3 into g. So we got the formula for acceleration here. This is a simple method which you are going to follow now. So once you get an acceleration here, then the remaining values are known to you. So m1, m3 and m2 values are known to you. Just substitute here and get the answer. Okay, so in this way, if you substitute the value of acceleration m1, m2, m3 values, because you know m1 is given here how much, 3 kg, and m2 is given as 2 kg, and similarly m3 is given as 5 kg. All these values if you substitute here by taking g is equal to 10 meters per second square, then you will get the value of acceleration. Okay, so once you get an acceleration formula here, can't you find out tension T1 by substituting here? Because once you know acceleration, you know the masses and gravitational force is known to you. If you substitute all these values, you can just verify the final solution here. Okay, so what is the final solution which you are going to get? You just see. So your answer here, I am writing, just verify the answer. So you should get acceleration, you should get an acceleration as 2 meters per second square, and tension T1 you will be getting 36 newtons, and tension T2 will be 40 newtons. Okay, these are the answers you should get here. So you can just substitute the values directly here. Acceleration will get, and if you know the acceleration, you substitute the value of acceleration here and get the tension here. If you know the acceleration, substitute the value here in the equation number 3 here. I am drawing the brackets at this place. So here also I am drawing the brackets because this is going to be T1. So you can find out T1, T2 and acceleration, because our question is also same. He's asking us to find out accelerations and tensions. Okay, so accelerations and tensions is nothing but, acceleration means you can find out acceleration, tensions means you can find out T1 and T2. That's it. Okay, so this is the formula you have to apply here. Okay, so I think it is easy to understand. You can just see here. So the formula for acceleration is m3 minus m1 by m1 plus m2 plus m3 into g. Okay, so this is the final formula you're getting.